types of bonding mechanisms, it is conventional to classify the bonds between atoms into different types as ionic, covalent, metallic, van der Waals, hydrogen. All bonding is a consequence of the electrostatic interaction between nuclei and electrons obeying Schrödinger's equation. Ionic bonding. Ionic bonding is the electrostatic force of attraction between positively and negatively charged ions, between nonmetals and metals. These ions have been produced as a result of a transfer of electrons between two atoms with a large difference in electronegativities. All ionic compounds are crystalline solids at room temperature. NaCl is a typical example of ionic bonding. The metallic elements have only up to the valence electrons in their outer shell will lose their electrons and become positive ions, whereas electronegative elements tend to acquire additional electrons to complete their octet and become negative ions, or anions. NaCl. Notice that when sodium loses its one valence electron it gets smaller in size, while chlorine grows larger when it gains an additional valence electron. After the reaction takes place, the charged Na positive and Cl negative ions are held together by electrostatic forces, thus forming an ionic bond. When the Na positive and Cl negative ions approach each other closely enough so that the orbits of the electron in the ions begin to overlap each other, then the electron begins to repel each other by virtue of the repulsive electrostatic Coulomb force. Of course, the closer together the ions are, the greater the repulsive force. Pauli exclusion principle has an important role in repulsive force. To prevent a violation of the exclusion principle, the potential energy of the system increases very rapidly. Property. Melting point and boiling point. The melting and boiling points of ionic compounds are high because a large amount of thermal energy is required to separate the ions which are bound by strong electrical forces. Electrical conductivity. Solid ionic compounds do not conduct electricity when a potential is applied because there are no mobile charged particles. No free electrons causes the ions to be firmly bound and cannot carry charge by moving. Hardness. Most ionic compounds are hard, the surfaces of their crystals are not easily scratches. This is because the ions are bound strongly to the lattice and aren't easily displaced. Brittleness. Most ionic compounds are brittle, a crystal will shatter if we try to distort it. This happens because distortion causes ions of like charges to come close together then sharply repel.